So to give you kind of a, if you were to just Google Snowflake reference architecture and get an example of what a Snowflake solution might look like, you might see a picture that would be a lot like this. And pretty much, Snowflake dominates the architecture picture. Not a lot of other layers in here. The layers are more of a kind of internal databases within Snowflake. And some things that might be a little bit glossed over are, how we're getting the data in and how we're consuming the data out, and some of the nuances of those layers. So what I hope to do is maybe show a slightly different picture, but still quite similar, of how maybe that Snowflake fits into the Azure world. And so there are still a number of layers within Snowflake that we leverage, and absolutely, there's a lot of benefits there that we'll speak to. But we can start to see that there's still a reliance on some additional tools. So in this case, to do some of that data acquisition and orchestration, we are relying on other tools to perform that. And maybe the raw layer that we might refer to as a data lake, maybe that could be served by an Azure service instead of Snowflake itself. And so one of the concepts we might talk about is, can we pair these up where maybe this raw data lake layer is in, say, an Azure service, but we're still leveraging Snowflake to get some of that data lake benefit as a semi-raw layer. And then we're going to talk a little bit on the analytics side. Is there still a role for Azure Analysis Services and Power BI, which are very common components of an analytical solution in the Azure world? So this at a high level is kind of the architecture that we're using at 6L, and we'll talk through a little bit of the reasoning as to why. And just because this is an Azure architecture, it doesn't mean that we can't have other tools. So just like that other picture showed, you can still have data science go directly into Snowflake or the data lake or even the analysis services model. And you can use other tools that they might prefer. So a bit of a disclaimer here. There's really lots of considerations that go into a solution architecture. So, why did we choose that? And some of those can also be very specific. So some of the scenarios that I'll be talking to as to why we chose a certain path, that may not be applicable to your specific use case or scenario. So there are things like, what's your skill set? And, budget, where do you have existing tools? There's a lot of other factors. I'll try to talk through a number of those. The goal here is to give you insight into the thought process I go through when trying to decide some of these things. But the reality is that I want this to be a two-way street. So there's experiences that we had and there's requirements that we had that may not be applicable to others. And I want to make sure that if you have a different experience, feel free to speak up or ask questions about that. And we'll try to give everybody on the call here a full perspective. And a little bit of a warning as well. We're going to go deep-ish. So to some extent, it's hard to talk about solution architecture and why we made certain choices, or maybe some of the technical challenges we had to overcome might drive why we're making a decision. So I'm going to attempt to give some insight into maybe what some of those challenges were. Also, based on the introductions, some people might just be interested in more about kind of the Snowflake solution in general. And like I said, my goal is really to talk about some of those handoff points of deciding what maybe can benefit from Azure versus Snowflake, where we have a decision as far as which platform that particular layer of the architecture should reside. But certainly, I'm open to any questions you might have. So like I said, I do want to keep it interactive. If at some point we go too far down a tangent, I might defer it till the end. But absolutely, I'm here to answer any questions you have today. So whether it's as we go along or at the end, throw them out there. This is all things Snowflake, so we can off-road at any time.
We've never had a problem with too many people trying to unmute at once, so feel free, and I'll keep an eye on the chat.
Thanks, Paul.
I thought we were going deep dish. You said it was deep-ish. I got hungry for a minute.
That would have been a totally different icon. Well, so with, I guess, you know, a good segue there. So with me, I have Eric Saminsky. And as I mentioned, you know, Eric and I actually worked prior to this project. There was kind of a version 1.0. We're refactoring a solution that was entirely Azure and now adding a Snowflake element to it. And so rather than me tell you some of the benefits of why Snowflake, I thought I'd have Eric here to help keep me honest as well.
Absolutely.
And we can go back and forth, Eric, but if you want to speak to some of these points, I'll chime in as well.
Well, I'll just start by giving a little bit of a preface. I don't think I did a great job during the introduction. Was that what we've done at 6Cell? So I mentioned that we serve the staffing industry, and the staffing industry is, you know, the manpowers of the world. They're huge, but there's 10,000, 14,000 of the medium to small size firms that all, you know, want data. But these are notoriously firms that don't have any you know, real reliance on technology, or I should say, don't have any technology acumen. They're using what they get from their vendors, and so we play a special niche to these smaller staffing firms. Where initially our company 6Cell was founded on the premise of integrations and migrations to these staffing applicant tracking systems that are specific to these firms. And some years ago, this idea came up that, hey, let's host basically a SaaS product, an online portal, where our clients can come into and see their data hosted through sort of our variation of the staffing world, sort of operationally, of a suite of reports, some self-service access. I mean, a lot of the same interactions with data that, you know, every one of you strive for in your companies. Our goal when we launched this product was to do this for other companies, sort of be their BI department, if you will. And I joined 6Cell when the product was probably 2 years old, but it really only had a POC client on it, and it was sort of still in what a barely MVP status. And I was challenged, if you will, with needing to roll on a lot of clients that had bought and were ready to buy, and also faced with limitations of you know, a product that wasn't really going to take us there. So what I kind of got an opportunity to start over. And if all of you are in the BI space and can resonate with this, most of us have walked into organizations, large, small, whatever, and they have a lot of debt. They have what they have, and you kind of have to absorb to that, and then maybe you get to pivot along the way and bring some cool things in. Well, being a small firm with 6Cell, we have no tech debt other than the cloud environment that we had in what Scott would affectionately refer to as 1.0. 1.0 wasn't going to take us where we needed to go, so let's start over, and let's start from scratch. And without taking you through the, you know, the cocktail napkins and things that this thing started as, one of the very, very key components was, where's our data warehouse going to live? Obviously, it's going to be multi-layered. It's going to have you know, raw, conformed, analytic, various layers, and I mean, any database platform is going to serve that up. But we needed it to be lightweight. We needed it to be portable. We needed it to be something we could afford, because we're, at our core, we're a consulting firm that provides services, and now what we hope is a SaaS product to a variety of clients in the staffing industry. So, and as every one of you knows, you can serve up all the great reports in the world, but there's always going to be a faction that says, well, I just want my data. Can I just have access to the data? And then we start getting into the conversation of, well, we got SQL servers over here, we got Oracle servers over here. How do we actually share that data? So all these things are sort of swirling around in my head. And I had some previous experience bringing Snowflake into Ahern. We were on, but when I left, unfortunately, I didn't get to really dive into it, but I was bought into the last bullet on Scott's slide. It was sexy. It was cool. It was lean. It was mean. It could do everything you wanted, and I didn't have to be a DBA to do it. Now, that's a bit of a
We're
mistake.
saying that was Eric's argument, and I tried to bring these other points.
Yeah, right. That's my only argument. I'll shut up in a minute here, but yeah, I mean, Scott would easily prove otherwise, that if it wasn't a DBA hat that you needed to wear, there was still another sort of integration data engineering hat that had to come with it, and he'll get into all those details. But if you haven't seen or heard about Snowflake's data sharing capabilities, this was huge. This was huge because our data warehouse no longer needed to be simply locked up tight in our, fireproof cabinet in the corner with some pipes of fiber into it and out of it. It would be something that ultimately becomes our asset, just as well as our culture, just as well as our people, just as well as our reputation. And it's something that we can share with our clients fairly easily. Simply, you spin up your Snowflake account, we can share it with you, and you take it from there. And without getting into the underpinnings of Snowflake, it's also very lean in how it manages its overall data platform, and so it's very cost effective. Takes a lot of administration out of the hands of, especially for a company like ours. We don't have all of those folks sitting around clamoring to get their hands into the pot of technology. And yeah, so I'll let Scott take it from here and fill in any gaps I might have left behind.
Great, thanks, Eric. Any questions for Eric before we move on? And I'll maybe touch on a few of these points yet, but I'll pause for a moment.
Unmute if you need to.
Okay, so as I mentioned, kind of my goal of this is to share kind of my thoughts as I think of it from a solution architect perspective. So if someone said, hey, I'm evaluating whether it's Azure Synapse or Azure SQL Database or Snowflake or something else, Google BigQuery, why might I choose this platform over another? And some of the differentiators that I see for Snowflake are, the biggest one I think is data sharing. And I don't actually have a slide that highlights the underlying architecture, but really the way Snowflake is designed is that behind the scenes, it's storing its data in blob storage. So in this case, literally, we're storing our data in Azure storage. You can't see it from the Azure portal, but it's still there. And it's in a Parquet-like format, so kind of a compressed format. And that really starts to play into enabling some of the capabilities that we see here. So data sharing, it's easy to share your data with someone else because effectively you're sharing access to that blob storage. You don't actually have to create a backup of a database, that is a couple gigabyte and send it to somebody and they restore it in their own environment. We don't have to duplicate the data in that way. We're simply referencing those same blob storage. And another feature that is, again, taking advantage of that is really zero copy cloning. So if you want to create a clone or a copy of a database, so you have a dev and you want to now create a test database with the exact same stuff, data and everything, you can clone it. And within minutes, you have a copy of that database. And it's because it didn't actually copy all of the data. It simply created another logical database, let's say, with references to the exact same blob storage files. As far as cost effective, this is something that if you're thinking of any cloud-based solution, really the cost savings come into play in your ability to pause or stop or scale the services. Meaning, in the end, most of the services you're getting what you pay for. So if you spin up a very large cluster or a very small one, as long as you're sizing it appropriately, a lot of the different solutions are cost competitive. But one of the big distinctions in pricing is whether you're paying based on consumption or capacity. So the difference there is consumption is like Google BigQuery, for example, you pay based on the number of megabytes or gigabytes you query. So the more data, the more cost. But if you don't do any queries, it could be free. And capacity is you spin up a certain size server, and as long as it's running, you're paying for it, whether you send a single query or not. And Snowflake is kind of in between those two, meaning you are choosing a size capacity for what they would call a warehouse. It's really the compute engine. It's what allows you to query that underlying blob storage or that data. And so you have to choose the size, but ultimately it has auto suspend and auto resume. So I don't have to choose certain hours where I have it running. I can simply send a query to it at any moment. It will effectively wake up, run my query, and then I can have it after a minute shut back down. So in that way, I'm getting closer to consumption-based pricing. It's a really powerful capability. In the SQL Server, in the Azure SQL world, you can stop and pause resources, but you'll find that that resuming process is closer to, say, 5 minutes. And people can call me out on how accurate that is or not. But what I can say is it's not fast enough where I could send it a query and have a acceptable user experience where that result will come back. In the Snowflake world, for the most part, it is. So it might not be milliseconds, it might be seconds or slightly longer, but it's a reasonable response.
Hey, Scott.
Yep.
So curious to get your perspective on this, but so I manage a Snowflake environment for a client right now, and you pay using credits, and I kind of view credits in Snowflake kind of like gas for like fuel for your car. The way we've experienced it is that if you have a really big truck, you use a lot more gas. So if you set Snowflake to run a really big compute job, it's like using a really big engine. And so you fire it up and you run it, and you put a lot of gas through it. So you burn a lot of credits, you burn a lot of fuel. You can run a small engine, but if you run it for a really long time, you end up burning a lot of fuel. We've actually found some techniques that we use where we've been able to use Snowflake on its extra small setting, so its smallest engine, and run it for a very short period of time and have it power our analytical environment. And it actually costs us just a tiny amount of money. It's kind of obscene, and I almost feel guilty for how inexpensive it is to run Snowflake in that platform. I'm curious, does that analogy fit with how you've seen it deployed? And are you seeing some specific scenarios where perhaps the cost is like less effective or more effective?
Yeah, so a few things there. So you're right. These warehouses, you can choose what size you want, and the one thing I would clarify is some people might say, whether you choose to have a large capacity or a small capacity, it would kind of even out, meaning with a small car, it would take 10 trips, to use your gas analogy. With a big truck, it would take 1. The big truck costs 10 times as much. So in the end, who cares if you pay for, 10 small cars or 1 big truck? But the reality is it can make a difference, because let's say that you only need it to move a little tiny bit. If you're still using that big truck, it isn't always going to be able to do it in 1/10 of the time. So in vice versa, you might, have a query that maybe can't parallelize as nice. So you do have to kind of watch that a little bit to play with kind of what's that right balance point of, many kind of smaller type clusters or one large one. Now, the other thing that I like about Snowflake is in the SQL world, the server itself has a capacity. In the Snowflake world, you can think of it as the data is blob storage, and then your compute engine or warehouse, you can really have any number of those all pointing at that same underlying data. So you can have one compute or warehouse for ad hoc queries, one that Power BI uses, one that your ETL process uses. So you can have warehouses designed around specific roles or types of workload that are then all sized appropriately. And then that helps you better fine tune the right size for those. So I'm not sure if I touched on each of the elements you were hoping to get there.
At some point, will you talk more about Power BI running on Snowflake or whatever other analytical platform?
Yeah, so I do have a slide on it. I didn't go into a lot of detail there, but I can talk about some of the challenges that we had around there and what some of the options are.
Okay, that I'll wait for that because I wanna kind of compare and contrast a couple of things that we found, then see kind of compare notes.
Okay, great. And the other thing worth mentioning is that so there's a lot of talk around data lake houses versus data warehouses, and do you need a data warehouse? Can you run all your analytics out of a data lake? And again, that's probably warrants a separate conversation all on its own. But some of the old, some of the underlying fundamentals of the architecture haven't changed, meaning blob storage is still going to just read a certain amount of speed. And compared to, say, solid state drives that are in memory, column store, that's going to be a much more performant query. So at the end of the day, a lot of these technologies are striking the right balance of loading the data from that blob storage in memory. And Snowflake is very similar. So if you were to do a query from cold, it would have to basically spin up that warehouse. Nothing is cached, and it has to read from blob storage to get that data in. Now, it can still do that relatively efficiently, so technology is getting better and better. But something to note that this auto suspend functionality where the warehouse will just stop after a minute, it's really cost effective, but the downside of that is you're weighing caching. So if you're going to shut it down and turn it back on later, your cache has essentially gone away. So depending on how you're using it for querying, you might want to leave that on and get some caching benefits, but at a cost, of course. All right.
So hey, Scott, this is Travis real quick from Sargento. So if you go back to that slide, one thing that I know I'm particularly interested in as being the BI manager is as we look from going from an on-prem to a cloud-based solution, and we deal with these consumption credits, one of the things that I get asked quite a bit by my management is, how do you predict what you're going to consume? And it's like the crystal ball effect of like, okay, I'm not sure how I'm going to answer this question. So is there a method or best practices that ultimately, because like I like Sean's analogy of this is kind of like the I consider it to be like an arcade game, right? Like where you're kind of feeding the tokens and you're like, hey, I want that stuffed animal, but hey, I'm short 500 tickets. Go back and play more and you can go ahead and get it. But it's not a guarantee, right? So this becomes like a marketing thing, right? Where you're trying to sell your management on these consumption credits, but it gets really hard to predict and to sell it, to be honest.
Yeah.
Any advice?
So I think this goes beyond Snowflake because, like I said, I think the auto suspend and auto resume is a powerful capability, but you still have to weigh that with caching needs and other aspects. So for any solution, the power of the cost effectiveness of the cloud, and this is in general, Azure, AWS, Snowflake, it comes down to scaling to only what you need, running it only when you need. So that dynamic scaling or suspending and stopping when you're not using it, that's really the key to savings. And what I like is Snowflake gives you more options around kind of divvying that up, and you can set different quotas for each of those. So I mentioned maybe I have a warehouse for ad hoc and a warehouse for my ETL and a warehouse for my tabular model processing or whatever. I could put a quota on each of those to make sure none of them are getting particularly out of whack or going rogue. So I certainly think there's some good cost management capabilities there. As far as how can you get really good at knowing the cost beforehand? other than, maybe some experience having rough things to compare it to, I don't know that there is a good way. In my opinion, the best thing to always do is to pilot it. Always start as small as you can. Scaling is simple, whether it's Snowflake or Azure. Start with extremely small. In the Azure SQL database world, I start with the $5 a month database, and I see how far that gets me. And you just keep going higher and higher until you need to. And hopefully, with a relatively realistic pilot, you start to get a better sense of what those true costs are going to be. Multiply them by 3. At some point, you'll want a dev test prod environment. So, you still have to do all those kind of calculations. But with a small pilot, you should be able to get a good baseline.
Yeah, that's really helpful. I mean, something that we struggle with is obviously as you look for annual budgets and these types of projected spend, it becomes kind of a roadmap type of dilemma where you're like, okay, what type of projects are we going to take on? And now we have to be better at estimating data, like you said. But I like your suggestion of start small, see what you can get away with to start, and then you can always expand upwards. But yeah, that's helpful.
And
thank you.
If I can even elaborate, Travis, a little bit. I mean, I think about when I ran a BI team at a big company. We had one server, and we were limited by the capacity of the server. It would only do so much, and every 18 months we'd have to beg IT, the department, come on, we need more. And so, okay, you're kind of incurring that expense on a recurring. It's like buying a new cell phone, right? Well, the difference with Snowflake, you can put a cap and say, hey, look, I'm only going to allow extra small usage of a particular warehouse. And if you do that and the warehouse runs for an entire day, you will know how much it costs to run that thing for the day if you've got it maxed out in capacity. We unfortunately figured that out the hard way. But I think the analogy...
I was going to say, anybody working in a cloud platform, any platform, you're going to have that one time where you realize you didn't set a quota or forgot to turn something off. And hopefully you learn quickly. So use those quotas, have it hit a certain high mark. Even if you're not getting remotely close, you never know when one developer writes some sort of horrible query that's going to just send that thing running for 24 hours.
Absolutely.
Yeah. And I mean, I think with Snowflake, start on the concept of starting small. What we've done is we've segregated the different capacities and by using different warehouse. So for ingestion, we might use one warehouse. For transformation, we might use another. For ad hoc usage, we might use another. And you got to start using it and start tracking it, and eventually you'll start to establish some concept of what a run rate looks like. Getting into, I mean, you can get into scaling Snowflake at a whole different level as well. But I think of it analogous to using the on-prem type environment where your costs are this until you hit a roadblock where your infrastructure just can't keep up with the demand. And then all of a sudden you hit a huge expense. And then your costs stay like and you kind of, where Snowflake, if you're tracking it monthly, you got a little bit more of this. I'm not saying your costs are upper or lower. They might be less, but it's a little bit more fluid with your consumption and your demand.
Sure.
And it will require you to bust open an Excel spreadsheet or query the Snowflake metadata or create a Power BI or whatever version of the report on it that you want to do to analyze it. But it offers you the ability to do that. So sorry, go ahead.
I'll agree with you, Eric. We have for our environment, and Travis, we found this really helpful. We have a dashboard that it happens to run on click. I think those of you who know me aren't probably shocked by that at all. But the APIs in Snowflake let you pull the data out, and we run that report, and that really helps you keep track of how your consumption is going. And we even set it up with an alert so that we know if something's gone a little screwy and you're using more consumption. And yes, like Eric, like I think you probably have had, we had a couple of months as we were getting our feet wet with it where the guys were doing some runaway stuff, and your eyes kind of pop out of your head when you see how many credits you burned through in those months. But Travis, the other thing we found is Snowflake and I'd love to find out from some of you who are also Snowflake customers. They kind of make it sound like they have a minimum amount you got to spend to get in the game. So we found that we had to buy a pretty substantial number of credits, and we actually got to the end of our first year with our contract, and we had a pile of them left. And there is a way to basically re-up and keep your credits without having to completely redo your whole contract. So
Okay.
we learned through that.
One more thing I would add is that by default, the quota is monthly, but you can change that to be a daily quota, which I recommend, because otherwise it can be too late. Any one day, it might be the first of the month where it goes rogue, and you might have been within your monthly quota, but you would have preferred to have stopped it earlier.
Now you tell me, Scott.
Highly recommend daily quota. Yeah.
I would.
Thanks, guys.
I would also offer to Sean's comment regarding contracts in Snowflake. That is it's probably another conversation that I'm happy to dive into, as I've gone in and out of that. We are not on a contract yet, and at some point it will make sense. But it's a beneficial cycle to be in. If you do it right, it can hurt you if you do it wrong, or they kind of push you into it. So I would just caution against that. They've gotten a little pushy on the whole contract front lately.
All right. Well, certainly, again, we can talk all day on those. So if you have more questions around the pricing after the main presentation, let's dive back in. But there might be other people that'll get some aspects out of the other layers of the architecture here. So I'll kind of go through this, and then we can dive back in if cost, and cost is probably one of the main drivers. So certainly happy to dive deeper on that too. But in the meantime, we'll dive into the ingestion piece of the architecture. So this is just kind of a picture of Snowflake, showing it where we can ingest data from various sources on the left-hand side. We have various options for getting the data in. And then, we have all these layers or zones where within Snowflake, we have, effectively these data lake layers or zones. And what I'm going to talk about right now is just the ingestion piece of how do we get data from these various source systems into the database. And you'll see kind of three that they outlined here: Snowpipe, Batch Copy, and Kafka. But the reality is there's a lot of tools that you could choose from. Azure Data Factory is one that we chose because we're in the Azure environment. So certainly, again, one of the considerations is simply what you already have a skill set for, an environment that you're already in with security and organization and deployment, DevOps processes, all of that good stuff. So that made Azure Data Factory a natural fit. There's lots of connectors. So as Eric mentioned, this is a multi-tenant solution, lots of different clients, all with their various types of source systems, multiple source systems. And we want to be able to get into all of those various systems and ingest data. So Azure Data Factory has those connectors for ingestion. It also helps orchestrate the overall workflow. So we can manage processes where we have kind of like, if anybody's used like integration services, SSIS, which, to be honest, I don't like. Azure Data Factory, I think, is a step up from that, and really lets us orchestrate the various processes that we need. It does have monitoring and alerts, but really one of the things that I'll touch on is this ability to rerun. So with any job, if you have certain points of failure, especially if you're talking lots of clients, lots of source systems, we want the ability to kind of, if something failed, to resume where we left off. And I think Azure Data Factory does a good job of that. It's cost effective for batch processing. Now note, I didn't just say cost effective. So I think every service has its strengths and weaknesses. And so I would say Azure Data Factory, its strength is batch processing. And part of it is just the cost structure that so there is a pay per activity. So what we found is in some cases, if we have to call a REST API, and it says, hey, 1 million objects changed. And now for whatever reason, we have to loop through and call an API to get each of those 1 million objects. Well, that's 1 million activities. So even though it might have only been a fraction of a penny per activity, I think it's each activity is half a penny an hour. It's something like that while you're running the activity. And so it's very low cost, but if you throw something like 1 million iterations at it, those can still add up. So generally what we do in that case is we might call out to an Azure application or function and let that application, where now we're paying for a capacity to run that service, but the application itself can loop through as many times as it needs to. So Azure Data Factory used in conjunction with potentially web jobs, functions, other PowerShell runbooks, there's a number of tools that it can orchestrate to accomplish what you want. So ingestion is kind of like finding the right tool based on the shape and volume and frequency of the calls. Okay, so we're using Azure Data Factory for the ingestion piece, but there's still the notion of, well, where should we ingest the data into? And is it a viable option to ingest it directly into Snowflake and use Snowflake as a data lake? And classic consulting answer is it depends. But I will tell you that some of the challenges you might encounter have to do with not having control over the types or the format of the data that you're going to get from your various sources. So to me, a characteristic of a data lake is the ability to support landing that data in its raw format. So if a client is giving it to you from, say, an FTP site and it's one big zip file, I want to land that zip file as is so that I know that if I kind of transformed it in flight, now if what was landed doesn't work, was that my process or theirs? So you kind of want that direct handoff where this is exactly the file that we were given. And so sometimes we don't always have control over the size of that file or the format of that file. And we don't want to have to do any kind of in-flight parsing. Now, again, this can be where different architects may have different feelings. Sometimes there's a little bit of transformation as you're ingesting. There's always a trade-off, but these are kind of what I look for in a raw data lake region. And I also like the limitless organization. Now, a data lake is really just, it's like folders and files. So it's like your hard drive, on your system. But the reality is if we're ingesting data from a number of different clients, each with a number of different source systems, and there's a bunch of different entities or objects within those source systems, and we want to keep track of when we got it, there's a number of attributes now that we want to be able to capture with that raw data. And so that can be challenging when you start talking about putting it in more of a table type structure, and using that term a little bit loosely. So what are some of the challenges that I see on the Snowflake side? Well, one is it does have a data type called variant. And in theory, that lets you store various object types. So you can put JSON in there, you can put Parquet objects and XML in there. But it does have a maximum size of 16 megabyte. Now, in most cases, that wouldn't be an issue. But in one scenario we had, it wasn't a good new line delimited JSON. All the objects were kind of in an array. So we needed a little bit of massaging to get out the individual objects. The complete file itself was, in some cases 20 some megabytes. So it just didn't work. And again, in the case of the zip file that I mentioned, it wouldn't be able to manage that if that was too large as well. So that's where landing it in maybe a separate blob storage and using something like Azure Data Factory to do that initial transformation might be a good idea. There's also some, you can't necessarily land all of the metadata you would want because those files would have to get stored in that single column of type variant. So it's kind of like the file goes there, but I feel like I miss a little bit of the delineation I get with my folder structure. And again, you can manage some of that with your schema name, but you kind of need multi-part schema name to replace all of that. So that's the driver for me believing that the data lake still benefits from having a true blob storage, such as using the Azure blob storage. And so that's why we're using that as our raw layer. Now that variant, sorry.
If I might add also, Scott, that as an organization that's looking to provide analytics of, not on our own behalf, but on our clients' behalf, and we also don't know where their sources are going to come from, just a truly raw blob layer allows us to store it as least structured as possible, and we can, if needed from an analytic perspective, bypass Snowflake if something just truly won't fit in a semi-structured or structured format. So having that first step as just give me it, whatever that data is, whatever that file is, just give it to me and let me hang on to it before I decide what to do with it is important for us, not necessarily knowing the types of sources that will be thrown at us by XYZ staffing company.
Yeah. Yep. I kind of view this as kind of a clean, well-defined layer. So raw does mean we're not messing with it, that it's truly the shape and format that we got from the source, or at least as close as possible to that. In the police terms, it's kind of like chain of custody. When I go back and look at this, I want to know that nobody interfered or altered with it, that was the true file that we received. But with that said, that variant field in Snowflake is still very powerful. So even though I might not use it as the data lake, that I still see a role for what I would call a true data lake, I still think it's really powerful. So kind of the compromise we made is we're still using what I would call a semi-raw layer. And so we're still storing the semi-structured content. So JSON files, Parquet files, XML files. We're still putting the complete and raw JSON or XML in there. It's just that maybe in here it got landed in a single JSON file that was 20 some meg, and we had to kind of break that down into kind of separate JSON files or a new line delimited JSON, one on each row, so that we could consume it into Snowflake within that 16 meg limit. And now each row can represent one of those objects. And then we're doing minimal transformation. So kind of how I define this is I want to parse out a unique identifier. So if there's a consistent ID field or some sort of primary key that I can get, and as well as the metadata. So I still have the file name that it came from. So I have that lineage tying it back to where in the data lake that file came from that I parsed it from. And then a row hash is really just a way to kind of look at, did the contents of this change at all? And all of this here, these two items, are really to help me identify whether there are any incremental changes or delta changes. So the first thing we do after we land data is we want to say, okay, now how do I, apply updates? Is this a new file? Is it an updated file? And parsing out minimal information to start to allow me to apply that logic is where I think there's value in this layer. And the other advantage is there's a SQL-like query language that then I can use against those files. Now, technically, this isn't a differentiator. So if you're familiar with some of the new Azure Synapse capabilities, they have a serverless compute that would let you likewise write SQL-like queries against the Azure blob files. So I think that there's more and more capabilities across the tools that do that. But regardless, it's definitely something that Snowflake also allows, and I think it's a great capability if you have a team with a SQL skill set. And I'm just going to pause for a little moment after each of these, so if you do have questions, feel free to chime in. Okay, so what does that semi-raw layer within Snowflake look like? Well, here's an example. So again, I might have the original file name that it came from in the data lake. I'm just kind of masking it here. So I know where it came from. I have the unique identifier. I have the raw JSON file itself, a row hash, which is just kind of like, you can look at it as like concatenating the entire record so that I know next time if I get that same ID record, I can compare these two values and just see if it changed. And then maybe a system modified date, or at least when I landed this, so some notion of an effective date for that record. And then I can use this to update kind of the next layer in our architecture, which will allow me to start to say, kind of the effective date and expiration date of any given record. Okay, so we talked about having the raw layer in Azure Blob Storage, a semi-raw layer within Snowflake. How do we get data from A to B? And effectively, what we have is we're creating a temporary table on the Snowflake side. And Snowflake has the notion of an external stage where it can reference Azure Blob Storage or even AWS, other blob storage. So effectively, we have a table that is pointing to the blob storage folder or files. And we can then use a copy into command that allows us to insert the files from the blob storage into Snowflake. And then if we do want to apply that delta logic, then we might have to write some additional code to figure out what the incremental changes are and ultimately write that to a persisted table. So this is what we're doing. We do have a true raw layer, but we're actually doing a little bit of logic in our landing process so that let's say that we're getting the same files again day after day and there's really no changes, or if we have to rerun a historical date and we already have newer versions of those records, we might not capture that. So this is just how we chose to implement it, so that at the end, we have a table where we can get the current version of all records in an easy to use manner, because that's what's most valuable to us for analytics. We still have those historical versions, but ultimately we want to get at an easy to query, what's my current version. Okay, so that's kind of the process behind the scenes, using that external stage to copy data into Snowflake. And there's still really two options of how we do that. There might be more, but Snowpipe is one option, and that's really an event-driven process. So what happens is you can have events in Azure. And so again, this really isn't specific to Snowflake. Azure has an event grid, and you can subscribe to events like every time a file is created or updated or deleted. So you can say that when I land files here, fire an event. But then what is on the Snowflake side is you can say when that event happens, I want you to automatically trigger that copy into logic. So that copy logic that we had, we can tie that to a pipeline and say, listen to these events and do this every time it happens. So if you had a bunch of individual records being streamed in to your data lake, that would be a great way for you to automatically trigger them coming into your Snowflake environment. Now, in our particular case, I mentioned that we're more batch-based, so we're not live streaming from the various client systems. We're going and pulling that data in many cases. So for us, we wanted to be able to orchestrate that as part of our Azure Data Factory pipeline, so using our ETL tool. And there we started to run into some challenges where we want to say, hey, I just want to insert all this data into Snowflake. And what we found is you still kind of have to fall back to that process that I had just described, where we have this external stage, so we kind of reference that and say copy it from there into here. And there are some limitations where you can't run multiple statements at once, and some people use Azure Functions. I'm glossing over some of the details here, but it's safe to say it's a little bit in flux. So the way that we addressed it is, so I mentioned we're using Azure Data Factory for the overall orchestration. This is going to be really ugly, but I'm going to show it to you. So this is kind of a sample of what we did. So we took our logic, and with each of those steps that I outlined for you, we wrapped it in a procedure in Snowflake. So this is something that we can call from Azure Data Factory and have it do each of those steps where we're creating that raw, that temporary storage. We're ultimately inserting the records into it from that external stage, and then we can do our delta logic and ultimately insert it into the final table. Now, if you're used to, say, SQL Server, when I say the word procedure, you might think stored procedure, SQL-based code. Unfortunately, in Snowflake, only JavaScript procedures are supported. So there isn't the notion of a SQL procedure yet. They may be coming, but that's not an option at the moment. One of the other challenges is that we didn't have support for dynamic SQL. So as part of our logic, let's say that we have a separate source database for each client. So we want to be able to specify which database we're inserting into depending on where we're getting the data, what partition in the data lake we're processing from. And there really wasn't a great way to just dynamically specify that other than using a procedure. So you can see here in a lot of cases, we're passing in variables, and then we're building a SQL string within the JavaScript procedure here and then executing it. So this is kind of the workaround to do dynamic SQL in a procedure in Snowflake. And there were also some limitations if we want to directly call a statement from Azure Data Factory. You can't put multiple statements all in one. If you're using kind of the lookup activity, it only allows one statement. So we found that calling a procedure allows us to have that one statement that lets us dynamically do as many steps along the way as we want. And this works really well for us.
How can you make fun of SSIS and then show us this?
Well, it's important to note that, when a lot of people talk modern workplace or modern BI solutions, I would agree. I almost see an irony in it that it often is more coding than it was before. So, for example, Databricks, so if we're writing a bunch of Python code to do the transformation, was that any better than me dragging and dropping something here? I just want to drop something that says copy data from A to B. And the reality is that if I were copying into an Azure SQL Server database and I already had relational data, or even in the case of JSON, if I want to just auto map the schema, I actually have a lot of options to do that. So frankly, some of this is I do not want to write JavaScript where I'm building a string and executing it. But at the same time, I don't think you want to overlook some of those other benefits that we talked about with Snowflake. So I do see this ingestion as having some challenges.
Yeah.
And
I think it's worth making a point here too. Nick Keen made a good point. Matillion has been one of his greatest friends for doing anything dynamic, and he's spoken about his systems and his systems at Snowflake before. So that may be something to keep in mind.
Yeah. And even when we do the transformation, what we'll find is that, ultimately, this type of developing your own scripts or your own procedures, it lets you get back kind of that dynamic element. So, this staging we're using for an entire system. So we're passing in the table name. The design pattern is the same. So we can use the same procedure for all of the objects in there. We don't have to write it for each of the 100 tables we might ingest. We're writing it once and just calling it for each of the entities that we're processing. So as long as you have a consistent design pattern, it might be painful once, but certainly there's a lot of reuse. That's the goal.
Sure, thanks.
Okay, so now that our data is ingested into Snowflake and we have that semi-raw layer, we want to do some transformations. And so again, since we're using Azure Data Factory to do that orchestration, we continue to, after we stage the data in Snowflake, we then continue to use it to orchestrate the transformations. And following a very similar process to what we just showed with using those procedures to kind of coordinate, we're doing something similar again here, where we are calling a procedure and we're passing in, say, the database name we want. Now, why are we doing that? And I think that one thing worth noting, which again, I don't go into a lot of detail here, is Snowflake doesn't really have a schema management solution yet. Now, it has lots of metadata available. So you can query any table viewer procedure. You can look at a last altered date. You can get the DDL for, the definition for that object. But ultimately, you kind of have to write your own script that would say, go through, find all the things that changed, build the string that says get the DDL for it, call it to actually get the DDL, and write your own kind of migration script, which is really tough to go back to if you come from a SQL Server world where there are the notion of database projects and DAC packs, where you can do state-based development, meaning you open up Visual Studio. If you want to change a table or a view, you simply edit it, delete that column, add a new column, rename this column, and then you just say deploy it, and the tool itself will figure out how to get from A to B. Where here we're in the world of I have to think through the SQL migration script I want to run to get from A to B. And another thing that the database projects in Visual Studio do for you is they have kind of the use of variables for any, what I would call a 3-part or 4-part reference. So anytime you have to reference a database outside of your database you're running in, or a different server in that case. And so in Snowflake, all of the databases are visible to each other. So our dev, our test, and our prod database can all be side by side, and I can call from any one of them into any other one. And that's powerful, but it can also be tricky in that, let's say that in my stored procedure, I say insert this into dev database dot, my schema, my table. Well, if I now deploy that to my test environment, when I call that procedure, it's still going to insert into my dev database that schema, that table. So you really want to avoid hard coding, that database reference. So we don't want to be explicit there. So if you're writing your own homegrown version control tool, you could try to do something similar to what a DAC pack would do, where you'd have kind of a placeholder variable that you would do your own. Every time you deploy your code, you'll do a search and replace on it. But our preference has been to just make sure we're not explicitly referencing database names at all. So in our case, the way that we address that is in the procedures where we do have to query from one database into another, and transformations are a good example of that. That we're actually, again, creating a procedure where we pass those in, then our code can refer to those parameters, and that way in the logic itself, it's never explicitly referencing a database. So now why do our transformations need it? Well, technically they wouldn't have to. Again, you have lots of options as far as whether you want to segregate your data by databases or just schema or something else. In our case, having a multi-tenant solution, so lots of different clients, it was important to us that each client had their own source database. And that way, if a certain client, eventually if we want to share that data with them or any other reason, we know that we can take that offline or online and it's specific to that customer. But at the same time, we're providing an analytics platform where eventually we want to put that into a conformed model, where across all the clients at some point, the data is client agnostic, source system agnostic, that we can build reusable analytical tools on top of it that apply to every client. That's where we get the benefit of that intellectual capital across all the clients. So inevitably, we have to go from a client-specific source database where our semi-raw layer is in source views and put it into a common conformed layer. And so that is a cross-database jump, and that's why we're using this approach. So again, there are maybe some different ways. In a SQL Server world, have done similar things, but there's a standard tool set, DAC packs, that kind of facilitate that. So it wouldn't necessarily be wrong to write your own homegrown solution that would do effectively the same thing, parameterize that, and kind of swap it and replace. But our preference was this.
Great. Where are we at? We want to make certain we get into that Q&A. How much time do you think you got here?
Yeah, I'll go a little bit quickly, and then we'll let Q&A guide where we go from there.
All right.
So ultimately, it means that we have different views. And so if you're looking at using Snowflake as a place to store your JSON, XML, et cetera, it's great that you can use SQLite syntax to query it, but it's something to keep in mind that at the end of the day, if you have a JSON object with 100 or several hundred attributes in it, you still have to ultimately figure out how to parse out the specific pieces that you need. So there still isn't really a shortcut to if it has an ID field and a name field and a type field, you still have to say, my variant column, whatever it is, dot ID, dot type. So again, we wrote a dynamic view that basically will go and look at all the metadata within that variant column, and it'll dynamically generate these source views for us. So it gives us a good baseline to parse that data out. Otherwise, if you're consuming hundreds of objects with hundreds of columns from all sorts of different people, hand parsing out each of those elements would be very time consuming. So it's another case where leveraging some sort of dynamic script that can turn that metadata into actual views is really powerful. And there is a link that I can share in here if people are interested. I did end up modifying it a bit for our own purposes, but the Snowflake community has some examples where other people have done similar things. All right, so I'm not going through a lot of the guts of our internal layer of Snowflake because, again, I want to talk about these boundary points. So hopefully, gave a little bit of insight into us, why we're using actual Azure Blob Storage for our raw layer, how we're using Azure Data Factory over this to orchestrate and move data into the semi-raw layer, and for better or worse, our use of procedures to kind of help orchestrate that within the Snowflake side. I definitely want to talk about the analytical layer and Power BI here. So we still do have data, kind of an analytical layer or dimensional model within Snowflake, but Azure Analysis Services and Power BI do have some distinct capabilities. And in Microsoft terminology, when they talk about BI solution architecture, they would talk about 3 distinct models. So one is that enterprise model that we might think of as a data warehouse, or a dimensional model, Kimball, DIMS, FACS. But another is a semantic model. And this is really a layer on top of that data where we can define measures and hierarchies, different calculations that, again, sometimes if that resides in each individual report, you might have inconsistencies. So the goal of the semantic layer is to really make that easier for end users to query. And of course, there's machine learning. I'm not talking about that today, and that really resides outside of both, the Snowflake environment anyway. So, what are some of those benefits of a semantic model? I did mention just kind of the generic benefits of a semantic layer, providing those single source of truth for certain key calculations, key performance indicators. But another thing to keep in mind is Snowflake doesn't really have the same notion of relationships, and it doesn't enforce constraints. So even something as simple as a primary key, you can define a unique constraint, but Snowflake will not enforce it. So one thing that can be a little bit eye-opening is once you actually bring it into an analytical model that has one-to-many relationships and enforces that, you might actually find that it might break in certain places. And that's really a good additional data quality check to kind of go back into your data and say, okay, this doesn't really fit the model the way I expected. Why is that? So I'm kind of surprised that you can't enforce the constraints, but you can define them. I don't know if that'll come at some point, but I really think having an analytical model then where it's enforcing those relationships and allowing us to define them as well as the measures on top, it's really valuable. And really, one thing, somebody asked about Power BI integrating. One reason why I really like having an analysis services model is the role level security. So Snowflake does have its own kind of capability around role level security, meaning you could write a query that would leverage the current role. However, that assumes that the user is logged in as themselves. So if I'm doing a solution like we are in a portal where I'm using, say, Power BI embedded to expose reports, the connection to Snowflake may not be that actual user, and that can make it a little bit more tricky. And also the notion of roles in Snowflake are just designed a little bit different, meaning at any given moment, you can be playing one role at a time. So I can't have the notion of a composite of various roles I might have, where analysis services might let me be multiple roles. So I could be a sales director here, regional manager there. And when I log in, I kind of get the union of both of those capabilities. So I think that Power BI and analysis services certainly play well together, and it's a highly performant, easy to use analytical model.
Hey, Scott?
Yep.
All right, so a couple questions on that side of it. When you're using the analysis services with Power BI, when Power BI runs its queries, are you hitting the analysis services server with data that's in it, not going straight into Snowflake for all of your analytical queries through Power BI? Does that question make sense?
Yes, absolutely. Okay. So, and there are various options that we could do. So one, if you're using Power BI Premium, for all practical purposes, I would consider that the same as Azure Analysis Services, meaning a dedicated capacity that is that tabular model. And Power BI itself, is that same tabular model. So to some extent, this model is inside of that. Yeah. The scenario you're talking about is Power BI using a live connection to the tabular model that's in Azure Analysis Services, and we're processing the data into Azure Analysis Services. And that is the scenario we're doing in most cases. Now, you could do a direct query where as you're kind of slicing and dicing your reports, those individual queries would go back into Power BI, or sorry, into Snowflake. But we're choosing to process the model here and then have that. So essentially our Snowflake, after we're done doing our transformations and building the model, that is suspending. So that billing is getting stopped. And we're instead then running the analysis services capacity.
So this exact scenario you described, if I were advising someone who's getting new into Snowflake, to me, this is like the biggest potential stumbling block for huge costs in Snowflake. Because I've talked to another organization that's been running Tableau, and their Tableau server hits Snowflake directly. So as their users are interacting with the Tableau dashboard, they're literally running queries directly against Snowflake to power the data back up in Tableau. And so remember that analogy of the fuel? They use a ton of fuel when they run Tableau. If you run Power BI in this architecture like you just described, you refresh analysis services on, say, a nightly basis, and your users running Power BI are hitting the analysis services box and not running Snowflake. Does that?
That's an excellent point, Sean. In fact, when we had that opportunity to quote unquote start over, we looked at Tableau, and I mean, I come from a Microsoft background, but I wanted to throw them up in the air and say, all right, which one's going to work here? And we had, once we started to get that picture of what Tableau needed to run, maybe the lack or less than sufficient semantic layer that analysis services provided. I mean, that's an excellent point. I mean, on all fronts, we felt Power BI was in the Microsoft environment was going to be better, but we also didn't want to be passing these queries to the Snowflake environment for every freaking click on the, on the website.
And,
to be honest,
we're running Click, and so we pull all of the data out of Snowflake and refresh it in memory on the Click box every morning. And so the users, you get hundreds of apps, and they're all beating on the Click server, and they're never touching Snowflake. So it just sits there idle like almost all day long, yet you're still running on top of a world-class cloud-based data warehouse that gives you all this capability.
Absolutely.
Yeah, so to be honest, I don't, I haven't done a more thorough comparison because it's not quite apples to apples. And what you really have to think about is, what would your usage pattern be? What are your performance demands? So if you were to leave Snowflake running the entire time, you're right, you're paying for a certain capacity at that point. So if you said you want a large and you leave it running 24 hours because people could query at any given moment and you want that cache advantage, you're paying for 24 hours of that capacity. But the same is true with Azure Analysis Services. It is a capacity that you're paying for. You can scale it up and scale it down. But at the end of the day, if you want that compute to be there, you can pause Analysis Services, but when you do, it won't even accept a query. So the one thing I like about Snowflake is if you were to suspend it, or the equivalent of pause it, it would still technically have a dial tone, meaning you could still send queries to it and it would wake up. But the downside is that it probably wouldn't be performant for our purposes of maybe wanting to surface that data in application.
Right.
1-2 seconds is kind of expected user experience, and it just wouldn't do that. So to me, I think you're kind of trading one capacity for another. But to me, Analysis Services isn't just the cost of capacity. It's a different architecture, meaning it is a true semantic model that has these additional benefits. So I believe in these benefits anyway. And if I want these benefits, then to me, that also helps become part of the motivation. And I want the ease of role level security and enforcing constraints. And
Paul, I need Dave Dunst. Where's Dave? I need Dave.
You wanted to talk about Click, I know.
Well, I need him to chime in and just let you. I mean, so you don't have that you don't have that limitation with the Click server like you do with the analytical services or the analysis services box. It's got the semantic layer built into it, and it's on all the time. But what you do need is you need a separate server. That's where the trade-off comes in. This environment I'm running right now, we have a physical separate box that Click beats on. They have a fixed cost for that, so you pay for it that way. Whereas the analysis services, you can scale it and do other things. I mean, you can ratchet it up as your environment ratchets up. Right. With Click, you will theoretically hit a max at some point.
Yeah, I mean, there isn't much way around having some sort of capacity that is going to meet the performance demands you have.
Yeah.
However, it is worth mentioning that Power BI does have a shared service. So if you just have Power BI Desktop and you deploy a report to the Power BI service, that is not a dedicated capacity, so it's not Power BI Premium. If you import data into that, you're not paying for the cost of hosting that. So that effectively is free. Now, there are limitations to the size of this model. Again, it is running in a shared capacity. So if you have an analysis services that you want to bump up to some incredible, gigabytes of RAM, you're not going to get that here. This is shared capacity. But for any kind of small data mart, many of us are running many reports in a shared capacity, and it works fine. Yeah. So frankly, you could start in this space where you're importing the data into Power BI, and then you don't even have that capacity cost at all. But at some point, you're probably going to reach a scale where, whether it's Power BI Premium or Analysis Services proper, you're going to want that dedicated capacity.
Got it. Cool. Thanks.
Yep. Okay, so, and I, even though I try to qualify it with this is a bit of a deep dive, there's a lot here, so I apologize for some of you that maybe just wanted that high level. hopefully we still broke it down in a way that was consumable. The key, maybe I should have started with this, you could have hung up after 5 minutes, but Azure does provide some valuable services. At the end of the day, whatever your data warehouse platform is, you still need some tool that's really good at the orchestration, that transformation, being able to rerun anything that failed, and having a good visual tool. So to Paul's point, we never want to go back and look at that code and that procedure. We want a nice visual that has green and red and said this failed and now click a button to try again. And Azure Data Factory provides that for us. And I want a true raw data lake where I can have that contract between all of the clients that I'm consuming data from, and not try to transform it in flight. And using Azure Blob Storage allows us to do that. And of course, the benefits of Azure Analysis Services, Power BI, they really do excel at that self-service side of analytics. So that semantic model is powerful, and I still think that's a really valuable layer on top of what might be the enterprise data model that might still be on the Snowflake side. But obviously, Snowflake has a lot of powerful benefits, and it having that semi-raw layer, I still think is great. And so we really have both, and we think that it, each has their unique benefits. And certainly using it for all of the various layers of our data warehouse. There are some trade-offs as far as how we're kind of moving the data within, but ultimately, it really enables some new business capabilities where we can much more easily share the data. If I want to share a database with another client, it's kind of backup restore or something else. And Snowflake makes that part easy, where clients can actually pay their own cost to use that data. I don't have to scale my server up to accommodate however many clients might be consuming, that I'm sharing that data with. So I think that's a game changer. And that ability to query it with SQL, that's not a differentiator anymore. Azure Synapse and other tools can do that, but it's still a great capability. And that auto suspend and resume, like I said, used well, balanced with whether you need caching or not. I really love that capability. So I think it's powerful, especially in the ad hoc. I don't have to remember to start the server up, do what I need to do, wait 5 minutes, shut it back down, or I forget to shut it down. I'm sending queries all day, working in it, and it just starts up, runs my query. A minute later, it shuts it down. I love how carefree that is, and we don't have that in, say, the Azure SQL database side yet. So combined, I think they provide a great solution, and overall, we're happy with it. So I know we went a little bit long, but I'm happy to take any other questions that people might have, dig deeper into other areas, or if you had enough Snowflake and Azure for now, we can always off-road from there too.
Sure thing, thanks. This is this phase of the Q&A. We'll have two phases. One that you got some questions you've been sitting on for this presentation material. Unmute and ask them now, or type them into the chat. The second phase, we'll get some chance for more questions for the group and internetworking. Get that camera on. So before I start bugging people about cameras, what's the questions for Scott that you might have been sitting on? Type them in, or feel free to unmute.
Hey Scott, I have a question about you had really good point about Azure being a good way to provide the orchestration, data consumption, and semantic model. And you talked a little bit about Azure Data Factory potentially reaching its limits depending on how you consume the data. Can you talk about maybe some other potential options for orchestrating data that you can use in Azure, and what are the pros and cons of some of those?
Yeah, and this is where I think it's an interesting world out there, and it really depends on your skill set. So more and more, I think our BI or data analytics field is kind of merging with custom dev. So if you have, say, a Python programming background, you might be really comfortable in Databricks, writing, Jupyter notebooks to, use code to connect to the various sources. And especially with more and more REST APIs, working with JSON, code is really well suited to work with that, meaning looping through, doing lots of calls versus kind of a batch-based tool that might grab it, compress it, move it. So I think, there's certainly options there. So Databricks, truly is one. What I like about some of these tools as well is that, they exist cross-cloud. So again, I primarily work in Microsoft, but a lot of these same technologies and concepts then can migrate into other cloud solutions. So, I've used Python in a Google Cloud Platform. And so those same skills transfer well, which is nice. For Azure Data Factory, I think it's really a convenient tool, but it's specific to Azure. So that could be a good thing, meaning it's a good value add differentiator. But it also, if your team is coming from another platform or already has coding experience, I think something like that makes sense. I use a lot of PowerShell, so I know that's not for everybody, but Azure has automation runbooks where you can put PowerShell in. So again, I can call different APIs to do any number of things. I can tap into Active Directory or other aspects of Azure. So I think Azure Functions, Databricks, PowerShell in automation runbooks, writing actual apps or web jobs, all those are on the table. And within Azure Data Factory, it has what they call mapping data flows. So that's kind of still that drag and drop experience where you can do transformations. Behind the scenes, it's actually generating Databricks. So if you want the power of Databricks but don't want to write it, mapping data flows within ADF is an option too.
Awesome.
And I guess SSIS, like I said, I'm not a fan, but that's still there. And you can even run SSIS within an integration runtime in Azure Data Factory. But I would say go for ADF.
Someone's raising their hand. Tim, you got to unmute. No? Going once, going twice.
Maybe it was a one-handed clap.
Yeah, really. Okay. Any other questions particular to Scott for presentation for this first phase of the QA?
I have one, Paul.
Go ahead.
And this is for Eric or Scott. So with your solution for your clients, you're doing an embedded application. Is that correct? Embedded
Correct.
Power BI?
Yep, Power BI embedded within a .NET web application.
Okay. And then is your company going to do any analysis of that data across clients? And if so, are they still going to go through Power BI and against the analysis services, or are you going to direct those straight to Snowflake? And what tool are you going to use for that?
There's quite a few pieces to that. One question. So are we going to analyze across clients? Yes. Do we do a lot of that yet? Not really, no, because the product is still, well, the redesign is still sort of in its infancy. And we also have to ensure that our clients are willing to participate in sort of a shared analysis, even if it's anonymized, it's kind of an enrollment
Right.
for participation. But as far as how we'll analyze it and how we'll serve it up, either or, all the above. The beauty of, I wish I almost would have given Scott part of my cocktail napkin drawing to show on his slide, is that the beauty of the architecture that we've gone with is that it allows us to give clients the ability to interact with the data at any layer that suits them, or allows us to interact with it at any layer that suits us. So if it needs to be at a more of a raw or strict data access layer, then we're going to go through Snowflake at, whether it's through the source data layer, conformed, or modeling, or if a client or a need were to require a more curated tabular model, semantic model, then we're going to serve it up in analysis services. So kind of all the above.
And
Okay.
then, maybe just another good general observation is that, there can be value in each of these layers, because more and more as companies migrate to software as a service, it becomes harder to have that direct access to your data. And any given portal, whether it's Salesforce or something else, might let you report on their data. You can't necessarily report across all of the various systems. And that's where, having somebody who's ingesting it, calling all the various APIs and things that are necessary, parsing through the JSON, and maybe can now give it to you in an easy to consume relational database, that there can be value in that on its own.
Yeah, it's always great to hear stories where you're taking data and serving it up as a software as a service. It's great.
It satisfies my desire for collecting and organizing things. Not hoarding. Collecting and organizing.
All right. Well, let's use this last piece here as people are starting to peter out. We have the last few minutes here to do a more open networking QA. Now, stick around and turn on your camera so that you can say hi to the rest of those that you haven't seen in the meetup in a while. And we can ask some questions of Scott or the group, but this is the point we try and get everybody's camera on. It'd be great to grab a screenshot of this large gallery preview with everybody's camera on. So if you're sticking around, it's because you're willing to have Paul bug you about having your camera on. So
on a nerdy note, Sean, I definitely would love to hear more about what you guys have done to optimize hitting Snowflake. How you've done it in sort of bite-sized batches and been able to reduce credit consumption. After we figured out our issues, we're okay. But man, if you've got some cheater tricks, you caught my attention.
Yeah, I will readily admit I've had to look over the usage statements many times to just make sure that this is going the way that we think it is, because it just it feels like we're cheating or something. And the best that I can come up with is so far has been that because we do so much of the work of on the analysis side, well, on the ETL on the analysis side, up and click on that box, all the users are beating that. It's like a force field to keep them from powering, from beating on Snowflake. So I think if you really put your analytical environment in well, and Scott gave a good example, and I think Nick's seen the same thing with using Power BI, and also who was it? Who's from Ahern tonight?
Justin.
That's me. I'm kind of new to the group, so I think this is my second time. I replaced Eric. I'm like Eric 2.0. They call me, so that's kind of. I go back with Eric. He's a friend, so I can rip on him a little bit. But hey, Eric, how's it going? So yeah, we have the same thing. It is
for the bigger and better option.
No, you teed me up, and now I'm rocking and rolling with it. So thanks, bud.
I think that's a really important model to take into account is where are your users doing all of the heavy analysis work. And there's future plans that we've got to do a lot more querying into Snowflake for some new marketing automation purposes and things that'll come up. And the more that we do that, we'll beat more on Snowflake and our credit usage will go up, et cetera. But for now, when you've got users just doing kind of your day-to-day analytical work, Snowflake with these other options has turned out to be a really, really cost-effective solution.
Nice. And Nick, you were full of all sorts of good commentary on the chat. Wasn't really questions, so I didn't insert them, but you had some high-level thing you wanted to summarize all the good things you were saying about your setup with Snowflake and Power BI. Take your chance.
Well, it's been almost a year now. And I definitely, made my life a lot easier. We were using Azure SQL and Azure Data Factory before, and then we switched over to Matillion and Snowflake. It's been a much, much better experience for a small development team anyways. So, and like being able to do the consumption control, like Sean was saying, you can really limit it down. And if you're a small team spinning things up, we do a lot, but it doesn't cost a lot. And it does feel like we're kind of cheating the system a little bit because we kind of do it in bulk at one time and then we're done with it.
Nice. All right, Skyline people, why is your new guy not got his camera on here? Steven?
He can't reveal the client work he's working on.
There we go. We're getting close. We got 19 folks. I think there's 14, 15 of you. And who am I missing here? Jorel. Yeah, I don't see you.
So I'm just kind of looking through the comments since I can't multitask. And I saw the mention of DBT, and And I'm not overly familiar. I'm just, roughly familiar. And Flyway, by the way, I didn't mention it, but that's another tool we might consider to automate. Right now, we're just manually kind of kicking off those scripts. And of course, I'm using PowerShell as well to kind of build it and whatever. But my understanding is it's a relatively similar tool. I think some point, if people aren't familiar on the SQL Server side, what capabilities of DAC packs and database projects are, I think that's an interesting topic. And doing a compare and contrast to something that's more migration script based, like a Flyway or DBT, I think would be potentially interesting, but certainly it'd be another one of those technical deep dives. So maybe we need some a break between.
I'll know more after March 1st when our new data engineer starts, but he couldn't, in the interview process, he couldn't stop talking about how much he loves DBT. And then I looked at the pricing and I'm like, yeah, I think I can throw a couple of licenses his way because it's not very expensive. So at some point here in the next few months, I'll be able to give you some firsthand experience on how well the DBT exploration goes.
I did also try to do my own, which if somebody wants to take my idea and make it $1 million idea, you can go for it. I've given up now, but I actually did. I did export the schema from Snowflake. I did all the data type transformations to make them SQL Server friendly. And then I imported that in a database project. And then I could actually use database projects to compare two environments, and it would generate the script for me, the change script. So the last step of that would just be switching all the data types back to a Snowflake friendly schema. I gave up on it, but I thought, if this tool already works, why not let it do all the heavy lifting?
So one of the things I did after we got into it, I mean, initially we were going to do a lot of inserting and updating our models, but it became easier with Matillion to run the transformations through and rewrite stuff, because especially while our models are in flux as we develop them, because it saves a ton of time. Don't have to manage the schemas and stuff. It just kind of I'll make a bunch of changes to the transformations, then just run it through all at once, and it updates all the tables, and then it's good to go.
And it probably depends on your workload. So if all of your data is in the data lake and you have a way to easily reprocess all of the historical partitions and kind of bring it through, then the data warehouse really isn't anything you don't already have a copy of. So then I think a lot of those scenarios become more possible. But if eventually you start implementing things like slowly changing dimensions and logic where you're kind of capturing point in time versions and the warehouse is the only copy, and then that's where you really have to be careful about preserving that data, because there is no other kind of copy of that history.
Yeah, I got a couple of those going right now, actually. So we do a little bit of combination, but for the most part, I try to keep that stuff separated and do most of our work just in the other models for Power BI. I mean, we've put all, like, semantically defined everything in Snowflake. We've tried to put as much of the KPIs in there so that when it gets into Power BI, it's really just kind of doing some sum measures and real basic work, so you don't have to recreate, like, every time you use part of a model, you don't have to recreate all the same measures and do a bunch of sum X's and complicated stuff in DAX. So that's how we've kind of done that.
Cool. I know like a general announcement that Eric Highland, he didn't stick around, that he wanted to mention was stuff's growing over at US Venture, and he hoped to let everybody in the meetup know that there was senior BI analyst roles opening up over there. So hopefully everybody's seeing similar amounts of growth and opportunity around data and analytics. So if you have any news to share or questions for particular people that you haven't seen in a while here in the group, go ahead.
Eventually, we're going to have to stop paying Skylines premium rates and start hiring internally, and we'll hit the ground on that. But in the meantime, I inherited the relationship, and I honestly wouldn't rather have inherited any others. So so far it's gone very well.
Let's say after all the Valentine talk we had, now you're gonna throw me under the bus. Who's the one constantly trying to, reduce hours and say, think about the budget, Garrett?
You, thank you. Someone's got to. I'm trying to get the product out, man. I don't care what it costs.
Oh, wait, my other coworkers are online. So no, I'm always trying to raise the hours.
Eric, I'll follow up with you when Scott's not around and see how you really feel.
So we're not going to get a book from you, Sean. Are you going to, spin off into something else that we can read?
Yeah, actually, getting close to launching our the Analytics to Win data governance assessment as the first online assessment. And the team I'm working with is putting together a series of remediation steps depending on how you score how your scores turn out from the assessment. So yeah, I've actually got a couple of guys over in Europe that are helping me with that, and it's gone super well. And there'll be some, basically your ability to automate your report. It'll automate your report for you when you get done, and then you'll be able to see your benchmark scores on how your data governance process compares against other like companies around the world that kind of fit your space. So some of that stuff's coming, and it's got a bunch of case studies and things in it that were, part of the book that we're ripping apart and putting into these online pieces. Nice. So I'll keep you guys posted when that stuff happens, because the initial data governance assessment part of it will be offered for free. And then if you want to get your customized report on how to do remediations, that's where there'll be basically a paywall, and you can kind of swipe the credit card and get your customized report.
Nice. Thanks for sharing.
Mm-hmm.
I'll make sure David Dunst knows that you were asking after him. He keeps telling me he has Taekwondo on Thursdays. So
he emailed me last week. We had a good chat.
Good.
We're working on filling the calendar for the rest of the year on presentations. Does anybody have any ideas or companies or technologies that they'd like to hear from? Solutions, case studies, client solutions? No?
We've had a really good luck with some panel type discussions that involve local experts. We've had David Dunst on it. We've had Eric Highland. So the reality is I'm taking the screenshot because now I have a list of people who I can kind of ping and say, you don't have to be the main presenter. You can just come on, be on a panel where we discuss a topic that relates to an interest in the meetup, and, have me as your moderator. Who could ask for anything more? So you right there, you might all be asked to be on a panel with each other. So be prepared for that. I'm getting my screenshot now.
I always welcome
any number of interesting topics, but I hesitate to bring them up if it means self-volunteering. But the lake house, data lake house. I do think you hear more and more buzz. It was already many years ago where, it was kind of like the data warehouse is dead. So I think there's some truth to those aspects, meaning it's evolving, it's changing. But I think if someone wanted to take on that topic and kind of say, how much truth is there to that? And, that could be an interesting one.
Yeah, I like that idea.
I suspect more and more solutions have a data lake element. It's somewhat inevitable with so much data. Like I said, software as a service, you're getting data in different semi-structured formats. So I think the data lake's there. It's always a question, then do you need the rest? And
Nicole, one that I would particularly like to see is less around the technology, but more around this change concept of potentially going from a traditional BI framework team into what I'm going to call a modern analytics team. And I think there's a lot of I'll say stories or journeys that companies have gone on that I'd love to hear in how they have made that transition, both internally with their, I'll call them analytics teams, but also externally with their stakeholders, right? As an organization, it could be fairly big, but you know, like I said, it's a journey that everybody kind of seems to tackle differently, and different organizations have different cultural challenges.
Sure. Thank you.
I think culture, especially your data culture, drives that structure. You know, a more data-oriented, progressive company is going to push the boundaries and kind of get past your lower level maturity and get into, you know, the more analytic space, to overuse the term. But the biggest challenge is that you could have the brightest mind in the most laggard of a company, and you know, they don't last long enough because, you know, if there's that mismatch.
Yep.
Mm-hmm.
Something I've noticed too is, you know, you mentioned like that center of excellence, you know, BI team that, you know, was thing of the past, but, you know, it seems like we're going towards that decentralized model. And the reason that I'm seeing is that you get people closer to the business who understand that process and that data a little bit more. So maybe there's a hybrid, you know, concept there that, you know, from a data engineer perspective, but from a data scientist, business analyst, data analyst perspective, you know, maybe that rest in the business side. So, but then I still see some of them try to go that center of excellence and it never seems to work right.
Yep.
Stephen, years ago, Gartner published a white paper on what they called the federated BI model. That is just exactly that, where you kind of architect your organization to have this central command and control for like data governance and things like that. But then what you do is you put people out as analysts in each of the functional areas within the business. They there report to the leader of that functional area. Like you have a finance analyst, they report to the finance leader, but then they have an official dotted line relationship back to the kind of the central office, if you will, the central data office or analytics office. And then they have regular meetings. They establish governance constructs there, but they do it with representatives from the business, almost like a data governance council. And then as new ideas are propagated or new measures, everything, right? That's your team to propagate that out to the rest of the business. And I've had a chance to implement that with a couple of different companies and have seen some good success doing that. And, you know, sometimes just changing what they have, the change process alone is worth the investment to just kind of shake things up and getting them to do something different. But
yeah,
but if you needed something, like you can probably Google the Gartner federated BI model, and that could be helpful in convincing, you know, an organization that it's been researched and that there's some weight behind it.
Sure. Thanks.
Yeah.
When I was at Cabela's, we used that model, and it seemed to work well.
Just think these days the volume of work exceeds the center of excellence.
You had me at data governance because really, you know, someone's got to set the policies and be the data police in that sense, and that has to be centralized. But how they own it and, you know, have your stewards out on the business side, so that makes sense.
I mean, you said it, the stewards or the evangelists. So Justin and I lived in that environment when we worked together at Direct Supply, and without that, you're doomed, because the influx of the need, the requests, the nonstop, whether it's a new thing or support an old thing, there's not enough to keep up. And so that guard, those folks that are out there kind of singing your praises and saying, all right, let's you know, let's get the best out of this group rather than get the most. And they're kind of the hybrid folks that can speak the language as well as, you know, live in the business.
We've had some successes with that kind of thing at PrimePack with manufacturing environment. We only have 40 IT people out of 5,000 employees, and our center of excellence around BI is really just people that help advise on how to best do some of their own things, and we establish great power users out there in that community, and trust in them to listen to our guidelines and that kind of thing. And it's been going pretty well. The challenging thing that on the flip side is there's those that want to latch on because they've always wanted to do their own thing, so they would have done it in Excel. Now they're doing it in Power BI. This kind of thing is some of those leaders out in those areas are kind of like, but I thought that's what IT did for us. Why don't you just make all these reports that we have? So I've had lots of conversations over the last 2 years being at ProMPAC with you have way more requests than there are people to do them. So I encourage you to learn some of this yourself.
Just let me teach you to do it the right way so I don't have to